नमस्कार दोस्तों, welcome again to my YouTube channel Man the Educator. In the series of my videos based on ISC 2025 physics paper, in last video I have posted about the marks weightage, chapter wise marks weightage, किस chapter से कितने marks का question पूछा जा सकता है. I hope it must have helped you a lot to plan your chapters and plan the examination of physics ISC 2025. As I informed you in previous video that the next video, the second video before the ISC 2025 physics examination, I will be posting a video on important derivations, chapter wise important derivations. As you all know, in physics, derivations are one of the important part of the physics question paper. So today I am going to discuss about important derivations chapter wise. Hope it will help you in your ISC 2025 physics examination. Starting with the first chapter, that is electric charge and electric field, part of electrostatics. Three very important derivations in this chapter, which is also you can understand the name of the chapter by Coulomb's law, commonly we say. Three important derivations. One, electric field due to an electric dipole on its axis, at a point on its axis, also known as axial or side-on position. Then electric field due to an electric dipole only, but at different position on the equator, equatorial or broadside on position. I have already given the formulas, actually which formula you have to derive on the screen, so you will be getting the idea from there also. And third important derivation, the torque acting on an electric dipole when it is kept in uniform electric field. Torque is equal to PE sine theta. These were the three important derivations from electrostatics, Coulomb's law. Now Gauss theorem. There are three important derivations from Gauss theorem. One, electric field due to a line charge, E is equal to lambda by 2 pi epsilon naught r, that one. Then electric field due to a sheet charge, charged sheet, that is sigma by 2 epsilon naught, E is equal to sigma by 2 epsilon. And electric field due to a hollow charged sphere. So three derivations important from Gauss theorem. Then comes electric potential and electric potential energy. The first important derivation from this chapter, electric potential at a point due to a point charge, that is V is equal to 1 by 4 pi epsilon naught Q by R. Then comes electric potential due to an electric dipole, same way like electric field, at a point on the axis of the dipole, side-on position, or at a point on the equator of dipole, that is broadside on position. And finally, the electric potential energy of an electric dipole when it is kept in uniform electric field, that is U is equal to minus PE cos theta, or we can say U is equal to minus vector P dot vector E, where small p is dipole moment. So these are the important derivations of electric potential and electric potential energy. Capacitors and dielectrics, the last chapter of electrostatics unit. First derivation, the capacitance of parallel plate capacitor, C is equal to epsilon naught A by D. Then capacitance of a parallel plate capacitor which is completely filled with a dielectric, C dash is equal to K epsilon naught A by D. Then combination of parallel and series capacitors. One, capacitance of a parallel plate capacitor when it is partially filled with dielectric slab, C dash is equal to epsilon naught A by D minus T plus T by K, that formula. So these are the important derivations of capacitor chapter. So we have completed the unit electrostatics. Now we'll move to current electricity. First derivation for current electricity is drift velocity. Drift velocity is equal to E, small e, tau, E, capital electric field upon M, this derivation. Then relation between current and drift velocity, I is equal to NAEVD. VD here is drift velocity. From the same relation, the relation between current density, J, is equal to NEVD. So these are the important derivations of current electricity. Effect of current. Obviously, one of the main topic is Biot-Savart's law. So derivations from applications of Biot-Savart's law. Derivation of magnetic field B due to a circular current carrying coil at its center, E is equal to mu naught N I by 2R. Then magnetic field due to a circular current carrying coil at a point on its axis to mu naught Ni A square upon A square plus X square. Another important topic of this is Ampere's circuital law. Two important derivations from this to derive the magnetic field due to a current carrying wire of infinite length, and then to derive the magnetic field due to a solenoid mu naught Ni, small ni, or mu naught capital N by L into I. Then force between two parallel current carrying wires, force per unit length, and using that the definition of 1 ampere, very important topic, maximum chance it can be asked. F by L, force per unit length. Per unit length mu naught I1 I2 upon 2 pi R. This one, this relation you have to remember to derive. Comes torque on current carrying loop when kept in magnetic field, that is tau is equal to mb sin theta, small m, magnetic moment. Then comes EMI, electromagnetic induction and alternating current. You have to remember the motional EMF, V or E, capital E is equal to BLV, then power, B square L square V square by R, that one. These two relations form EMI, electromagnetic induction. Then the self-inductance of a solenoid as well as mutual inductance of two coaxial solenoids. Self-inductance of solenoid, L is equal to mu naught N square A by L. Mutual inductance M is equal to mu naught N1 N2 A by L. And from alternating current, the mean value of current, I mean 0.637 of I naught, and the RMS value, I RMS is equal to 73.1% or 0.731 of I naught. First, using the phasor diagram, one of the easiest derivation. Z is equal to under root in bracket XL minus XC whole square plus R square. And tan theta is equal to XL minus XC, where tan phi actually, tan phi is equal to XL minus XC by R. So these two from alternating current. Then comes optics. First, ray optics. In ray optics, first important derivation which you have to remember is refractive index in terms of minimum deviation. That is, N refractive index is equal to sine in bracket A plus D minimum by 2 upon sine A by 2. This derivation for prism. You must, using the prism, you must remember. Then refraction from spherical surfaces, either concave or convex, you can use. Always remember the importance of diagram in any of the derivation. Refraction from spherical surface, N2 by V minus N1 by U is equal to N2 minus N1 by R. Important derivation. Comes lens maker's formula and lens formula. I will advise you to remember the lens maker's formula, from that only to derive the lens formula, so that both derivations you can understand from the same word. So lens maker's formula, 1 by F is equal to N minus 1 in bracket 1 by R1 minus 1 by R2. Similarly, two more steps you will do, you can prove 1 by F is equal to 1 by V minus 1 by U, that is lens formula. So these two important derivations from lenses, refraction from spherical surfaces. Then comes optical instruments. Very, very important chapter for diagram. You must remember the derivations of magnifying power for compound microscope for both final image at D and final image at infinity. Same way, you also must remember the magnifying power of refracting telescope for final image at D and final image at infinity. Wave optics. First thing, you have to remember Huygens principle. One of the most important, surely going to be asked topic. Show or prove laws of refraction by Huygens principle. Another one, prove laws of reflection by Huygens principle. Out of two, one can be surely asked in your IC paper. Then comes Young's double slit experiment, fringe width, beta is equal to lambda, capital D upon small d. Also, for diffraction, the maxima condition, E sin theta is equal to m lambda, that one. Okay, so you should remember these two. Okay? Dual nature, atoms and nuclei, and electronic devices, last three chapters. Good news, no derivation will be asked from these three chapters. So, I have already discussed in today's video what are the important derivations chapter wise. Hope in last minute revision it is going to help you. Again I am telling children, diagram, supporting diagram for each derivation you must remember properly. Little bit describe your diagram, show the important steps, and wish you a happy preparation. Revise in remaining 2 days time. And in next video, as I promised in the first video for ISC, that I will be posting 3 videos before your physics examination. First one, marks weightage chapter wise. Second one is this one, important derivations chapter wise. Third video I will post one day before the examination for last minute tricks, tips, important questions. Not only that, keep on following my channel so that all of you are in important class of your life, class 12. I will be keep on posting the videos on future prospects, courses, careers. Not only that, how to get admissions, what are the different kind of examinations you can appear, all the details I will be keep on updating on my channel. So hope you will take the full benefit of the channels. Please like, subscribe, comment. Don't forget to press the bell icon so that you will get the notifications first. So till I will post the next video. Bye bye. Take care. Do your examinations well. Prepare for your physics examination. Bye bye.